So hello and welcome to today's class. In this chapter so far we've investigated methods of finding turning points, asymptotes and points of inflection of various curves. We're now going to use this information as well as our knowledge of roots of equations to make a sketch of a curve without going through the fairly tedious process of having to plot a large number of points. So in today's lesson we're going to start off by drawing a rough sketch of the curve y is equal to x squared minus x minus 6. So we'll start this process off by finding where the curve intersects the x and y axes. To do this, we let x equal to 0, we find the corresponding y value, and we let y equal to 0 and find the corresponding x value. In this instance, we will end up with y being equal to minus 6. So where our curve crosses, the y-axis is at 0 minus 6. We'll use that information later on when we draw the curve. To find where our curve intersects the x-axis, i.e. the x-intercepts, we let y equal to 0 and we find x. So x squared minus x minus 6 is equal to 0. This is a quadratic, so we factorize the quadratic. Our signs are plus and minus, minus 3 plus 2, and let that all equal to 0 so we can find the roots. The roots of our expression, therefore, will be x equal to minus 2 and x is equal to 3. So therefore our curve crosses the x-axis at 2 points, which makes sense because it's a quadratic curve. It crosses it at minus 2, 0 and at 3, 0. Now, what's left to do? Now we're going to find out if our curve has a turning point, and then we need to decide if it's a maximum turning point or if it's a minimum turning point. So, how do we find if a curve has a turning point? From our recent studying, we know that dy dx is equal to 0 for turning points. So let's calculate dy dx. Let it equal to 0. So that'll be 2x minus 1. Let that equal to 0. Therefore 2x is equal to 1. X is equal to a half. That's our x coordinate. To find our y coordinate, simply plug this value, x is equal to a half, into our given function, y, and when we do that, it results in y equal to minus 6 and a quarter. So the coordinate of our turning point is a half minus 6 and a quarter. Now we don't know if it's a maximum turning point or if it's a minimum turning point, so we carry out our second derivative test. So d squared y dx squared is equal to 2, which is greater than 0, so therefore our turning point is a minimum turning point. So at this point we're ready to sketch our graph. So let's draw our x and y axes. So make sure your intervals are all the same on the x-axis and they're all the same on the y-axis. So I'm going to go up 1, 2, 3, 4, minus 1, minus 2, minus 3. And in our x values, I'll go up in 2s. 2, 4, 6. Minus 2, minus 4, minus 6. So first things first, I'm going to plot the points I've just found. So I'm going to plot 0, 6, where the curve crosses the y-axis. So 0, minus 6. Which is, which is here. Where's my curve cross the x-axis? At minus 2, 0, and at 3, 0. And finally, let's put in our minimum turning point, which is a half minus 6 1/4. So it's going to be just about here somewhere. Now, let's draw our curve in one continuous motion, going through each of the points we've just found here. So hopefully I have a steady hand. And there you have it, a rough sketch of the curve y is equal to x squared minus x minus 6, using knowledge on roots of equations and turning points.